We are going to start today's class with a condition, something called unitarity in scattering. Unitarity condition है scattering, which we are going to see how we can see the unitarity. Unitarity in all जो quantum mechanics में आपने studied is that u diagonal u is 1 or u is equal to u inverse at this optical definition. अब यहाँ पर हमारे पास जो incoming particles and outgoing particles हैं before and after scattering. So what will their scattering cross section be? That is going to calculate, and there has to be seen vis-a-vis this scattering condition. So अब हमारे पास what we are seeing that the unitarity condition for scattering. So for example, if you remember हमारे पास जो scattering है psi for incoming and outgoing wave, it came out to be like this: f of theta is equal to iota t dot r by. So you knew ये f theta how we represented it in the previous thing, how we represented f of theta and this thing, and how we modified our general scattering for signal. The same thing can be written as psi can be approximately written as e for iota k n dot n bar plus 1 by r f of r. So ये वाला formula है, we can write it like in some altered way like this: f of n prime e for iota k dot r, where n and n prime जो हमारे पास हैं they are what? Where they are two unit vectors. One is its direction in the direction incident to the direction of scattering, and the other is along the direction of the scattering. One is incident to the direction of scattering, other is along the direction of scattering. So incident angle क्या है, और we'll take these two represent n points, and not only or an angle between them. अब ये है कि so if we multiply this equation by arbitrary coefficients f, so इसका form जो हमारे पास equation का आएगा, it will be f into f of n e to the iota k or n dot 1n plus e to the iota k dot r by r. This is an altered formula. ये हम यहाँ लाएंगे. So we have to multiply it by some arbitrary f of n prime du. And we are multiplying it by some arbitrary coefficients and see what I should say our all range of direction जो उसका scattering angle हो and solid angle होगा du, and accordingly this will so उसकी scattering क्या होगी along all directions within solid du. So n can have value n is equal to plus minus n prime. तो ये है कि value of n can be within the regions of n, which may be plus minus n, and f of n can similarly be plus minus is approximately f of minus n, which is taken outside the integral. So if we just calculate the integral here in this form, so it's another job how we can calculate this integral. So So if we omit the common factor of 2 pi iota by k in this sense, so this is integral का form पहले हमारे पास आएगा, it will take this form 2 pi iota f minus n e to the power iota k dot r dot n p dot r by kr minus 2 pi iota f n prime. This is minus n, this is n prime e to the power iota k r by kr plus अपना वाला ये वाला. So you have to just see this integral इसका you can see in terms of this. You can just see once we just this complex integral to see, we can write it in this way, and this one is अपना वाला. It's like this. F of n prime n f of n. So this is in the concise operator form, and if you are going to omit this 2 pi iota by k, 2 pi iota by k, omit करेंगे, so इसका form जो आएगा e to the iota minus k dot r by r f of minus n minus e to the iota k dot r by k r 2 pi iota f of n. But we will have a factor of s here. This is the thing. What is that s? S is basically s is 1 plus 2y iota k of f, where f is the integral operator, which is defined as f. Will define it as f of n को हम ऐसे डिफाइन करेंगे, f of n we are going to define it like integral of 1 by 4 pi f of n prime n f of n. This is the solid angle. So the operator s जो हमारे पास है, it's also called scattering operator or scattering matrix भी also. So you can see from this, you can see s को हम as diagram में कर सकते हैं. It will be minus iota to iota kf. फिर s diagram will come out to be 1. You can see this is a property. Or from this you can say f minus f diagram. You can also write it as twice iota k f f diagram. अब ये from this whatever the algebra we have done, we can talk of the unitarity condition for scattering, which will be of the form this f of n minus f of n prime then f of and we're going to use this equation, this. So if we multiply f of f, this twice f of n prime minus f star n prime, because we are going to see this f minus f is equal to this okay. So once you do this, you can see it's equal to iota k by 2 pi upon it's basically it's this is 2 pi 2 iota k or 2 iota k f. So we have written f of n star and n double dash f star n of n du for n is equal to n prime. The integral on the right side of the equation is just total scattering cross section sigma. which is basically equal to, if n is equal to n prime, you can see it. If it's n prime square, basically. You can see if it comes out to be n prime square du. So this is the scattering cross section जो हमारे पास आएगा. So this is the scattering cross section in the sense that we have arrived at what I should say, scattering cross section. This is the solid angle. This is the scattering cross section which we arrived at. And if it's static sigma, so if you n is equal to n prime, if f is equal to f star, twice f आएगा, so imaginary f of n is equal to k sigma by 4 pi. This is also known as optical theorem of scattering. So this is the general, the way we have unitarity condition, U dagger is equal to 1. So here we have doing the same scattering unitarity conditions for those scattering formula, where we have this incoming wave as well as scattering wave, and how we can impose scattering conditions. The only thing is that how we can solve this integral, how we can write it in terms of the difference of these two, and imposing and having the idea S coordinate how we can arrive at it. And we could at the end arrive at scattering formula, which is also known as optical theorem for scattering. अब ये है कि we can use another property of, जिस तरह हमारे पास property है, if you remember, time reversal property या requirements of symmetry which we impose upon them. How will this wave function or this formula, ये वाली formula, this formula, yeah, this formula, this formula basically. So write it. How we can write it when we root it into S? We write it like this formula. I have to solve e to the minus iota k dot r where r f of minus s minus s f of n. जब में s है तो इस formula को here how can write it in terms of if you want to impose if we see symmetry condition, if you remember, once we had anti-unitary condition, the anti-linearity condition, which imposes complex conjugate in that operator. So how will it will have some correspondence to the physical phenomena. In the same way, जो हमारे पास यहाँ पर ये है f conjugate, if you are going to impose have a complex conjugate, which means as if we are imposing symmetry conditions. We are imposing symmetry conditions. Then, how can we explain things? So if we have this condition, if we have this formula, how can we impose symmetry condition? So we can have. If we say psi has some state, we also assume that psi now conjugate will also have, it will be also a description of some state, which was previously shown in that in the case of anti-linearity condition, the imposition of complex conjugate, it also had some physical correspondence. उसको हम शायद कहते थे Kramer's what I should say condition, which had some physical correspondence map. So in the same way, if you change the side to side line for this scattering condition, तो हमारी जो state है equal iota k dot r by r f star r minus n minus e to minus iota k dot r by r S star So to describe the unitary condition. Psi that S star f of star n prime is equal to 5 minus n. So you can define an arbitrary function by putting this an operator operating on this should be equal to this. So if you use unitary operator of operator S such that f star n prime is equal to S inverse phi of minus n is equal to. So you can have S star inverse, you get S back. So minus S 5 and n star. So which means using operator p prime, p of the inversion, p we can use it as an inversion of coordinates, which changes f of n, who star n is changed. If you have an operator operating on this thing, it will be minus p of, so f can be in terms of S diagram. X1, so we can have S basically P of phi of n. You can write it like this. Where n and n are two unit vectors. One is along static and along other is. And the angle P along the direction of scattering, along the other is direction. One is direction of incidence of the particle, and other along direction of the scattering. So here what we have done, we have only imposed anti-linear conditions. Here we can say that this psi star will also comprise the state. तो जो हमारे पास scattering formula है, if we change f star, it will give this condition. So this means that for a time reversed wave function, e to the power minus iota k dot r phi of minus n prime is equal to e to the power iota k dot r p of s p phi. So which again shows this p of s p will be equal to s p of s p is equal to s. So these two functions will depend on arbitrary functions, differ only in the notations of the functions. And further, you can say that just like we arrived at this scattering thing, we can see that to transposition interchanges initial and final vectors and an n prime, while inversion changes sign. So transposition interchanges initial and final vectors, while inversion changes sign. What does it mean? It means that s of n, it is a transitive function. It will change of sign. And s has been defined here like this. F and f can be f is basically जो हमारा f है वहाँ पर f is how we define the incident and the scattering. So as data S will come out to be this one. So this is the unitary condition. So S is defined in terms of f. So S diagram is f star, so we can have the incoming and the scattering wave. So it comes into this scheme. So at the end, if we have inversion, if we have transposition, this change to this If you transpose things, so there will be change of sign. Or f of n of n prime, if you have inversion change sign. If of f n goes to n prime, then this goes to, then it will change sign, minus n prime minus n. This, the previous thing was called optical theorem for scattering. This is known as reciprocity theorem. This means that amplitudes are same for two scattering processes, such that each is time reversal of the other. Yes, yes. And time reversal change initial state to the final state, and reversal is the direction of the. So time reversal change, initial change goes to final, and reverse is the direction of the order. And this is corresponds to something called reciprocity theorem. This is the optical theorem. So the only thing is that how to change this thing, how we can have a psi goes to psi as a linearity condition. So you can psi star also is a state, and it has some physical correspondence. If you take this very consideration, and जो हमारे पास ये formula ordination थी, and we are going to impose this condition in terms of S, as like S is unit matrix. So इसमें ये condition impose करेंगे in the original formula. We can, under the change of sign, it will be same until goes to final. So this is the thing we have done today. So we'll stop here.